Another topic will be covered in your test 4 is 9.3, the system of linear inequalities. Remember in section 3.6, we talk about how to graph the linear inequality. So this time we will talk about the system of linear inequalities. So let's check how can we graph if we have more than one linear inequality. So let's see if we have this system of inequalities. So first step, we need to work on each inequality, try to graph each one. But this time we're going to put them in the same system, same coordinate. So for example, you still remember how to graph the linear inequality? If we have the first one, we need to set them to be the equality because it's the boundary line, right? So the first one, we will set it to be an equation 3x equals y because this will be our boundary line. So we find several points, right? We find several points. And we can list x, y to find the several points. Maybe this time we set x equals 1, then y equals 3. X equal to -1, y equal to -3. Okay? If you want, you can also set x equal to 1, y equal to x equal to 0, y equal to 0, sorry. So we have several points. X, 2, 3, y, 1, 2, 3, -1, 2, 3. So 1, 2, 3, -1, 2, 3. So first we will have 1, 3. So that will be this point, right? This point, and the -1, -3. So that will be like this point. And we also have 0, 0. So we can connect them to have a straight line. And here I use the solid line because we have the equal sign in our original inequality. So this one should be the solid line because it's possible to get the solution right equal to 3x just equal to y. So this will be the solid line. Okay, after we have this boundary line, we should set which part is our solution for the inequality, right? We use a dot to test. Maybe this time we use 1, 1 to test if it's possible. We use 1, 1 to test if it's true for the inequality. We have greater than, or we'll have this part, 1, 1 to test. Then we use 1 to replace x and 1 replace y. We got 3 greater than equal to 1. So we will say it's true. 3 is greater than or equal to 1. So this point is the solution. So we will say this part contain this point is the solution region for this equation, for this inequality. We use this point to test, and this point is true, is the solution. So we should shade it the part include this point as our solution region. So we will do the same thing for the second inequality. Let's see, second inequality, we have x plus 2y equal to 8 as our boundary line. So we will also set several values for x, y. If x equal to 0, we will get y equal to 4. X is equal to 2, then y equal to 3. X equal to negative 2, then y is equal to 5. So we can use the several points. 0, 4. So it will be like this one, 0, 4. Next point, 2, 3. So it will be 2, 3, like this way. 2, 3, right? So another one, negative 2, negative 5. So negative 2, negative 5 will be like this part. Hold on. 2, 3, negative 2, 5, 0, 4. Sorry, it's not this one. Negative 2, 5. So it will be negative 2, 5. Will be this one. Now I will connect this point to be a straight line. I also use the solid line. Right? Because we also find the equal sign here in the second inequality. So it's possible to be equal to 8. So I will put the solid line. Now I'm going to use a test point. So this time maybe we're going to use this point as our test point. A negative 1, 1. Negative 1, 1 as our test point. Then we check if it's true. So negative 1 to replace x and 1 to replace y. Left side we get 1. 1 is less than 8, so it's true. So this is the solution of this inequality. So we should shade the part include this solution, so there will be this part. So after we draw two inequalities on the same system, now we know the overlapped part is our solution. The overlapped part is our solution. Okay, so here we know which part is overlapped, is this part. So we know this is the solution for the system. Is the solution for the system, solution region. Okay, it's just the solution region. So first step, we should draw the curve, draw the inequality. How can we draw the inequality? We still need to set the boundary line. We still need to set the boundary line, right? So for the first one, we use 3x equals y to be our boundary line. And we select several points, then use this point to help us draw the boundary line. But which side is the solution part for the inequality? We need to set the test point. So here, this is the test point. We pick one test point and we know if the inequality remains true, then that test point is the solution. So we should shade the part include this point. If the inequality becomes false, then we should shade the part without that test point. So here we shaded this part. Second, we still use another equation to set the boundary line. Then we use several points to help us to draw the boundary line. We also use the solid curve because we also have the equal sign in our inequality. After that, we need to decide which side is the solution region, right? We still need to set the test point. We pick this as our test point, and we know the inequality remains true. So the region should include that test point. We shaded the whole test point. Then we try to find which region is the common region, overlapped part. So we shaded the overlapped part by using the blue one. So that's how we get the solution for the system of linear inequality. Okay, so you will have maybe 2 questions like this in your test 4. So this topic is also included in test 4.